Okay, this will be 3.2 homework, implicit differentiation. Very tricky kind of a thing to do, but let's give it a go. So, for implicit differentiation, you're going to have equations where it's not solved for y, and we call those equations explicit. But as you can see here, we have x squared, we got y plus x and y squared. Y is not solved for, and a lot of the times y can't be solved for. And so in that case, it's just, we use implicit differentiation. And for this problem, I'm going to rewrite it to kind of explain what we're doing here. I'm going to, instead of saying y, I'm going to write it as f of x. And then x, and then we'll have f of x squared equal to 6. So basically, implicit differentiation is just the chain rule, except we don't know the inside function. We basically just don't know the inside function. And so we just use general notation. So as we take the derivative of this equation right here, we have x squared times by f of x. We don't necessarily know what f of x is. F of x could be x to the third. F of x could be sine of x. F of x could be tangent of x. Whatever f of x is, the function is, this is the explicit form of the function. Y is the explicit form, which we don't know, which we don't know. And so we're going to have to use the product rule when I take the derivative of these two parts right here, because we have x squared and we have this function, which again we're not really sure what it is, but it is a function of x, so that's a product. So take the derivative, we'll have to use the product rule, so that's going to be the first times the derivative of the second. So that's going to be times by f prime of x. And then plus the derivative of x squared, which is 2x, times by the second. Plus, now we'll use the derivative of this term, but we'll have to use the product rule. So we'll take the first times the derivative of the second part. Now this is where right here, so when I take the derivative here, we'll drop the 2. So there's an inside and there's an outside part. And so this is kind of the tricky part of implicit differentiation, but it's easier to see if you use function notation rather than y. But you'll drop the 2, so times by 2, and then we'll have to keep f of x there, but then we'll have to multiply by the derivative of the inside, which is f prime of x. So we did the first x times the derivative of the second, which was this part right here, which required the chain rule, and then plus the derivative of x, which would be 1 times by the second, which is f of x squared, equal to 0, because the derivative of 6 would be 0. So there you go. That's pretty much what you would do. Now, the reason why I chose to write it in function notation, just because it's easier to see where the chain rule is going to happen. But I'm going to do this example without using function notation, because typically it's just easier whenever you get the hang of it to just write it without function notation, but it's harder to see when you need to use the chain rule. And so I'll do the same exact example again, but without the function notation. So we'll use the product rule. So that's going to be the first times the derivative of y. That's going to be y prime. So instead of using function notation, we're just using y notation. So this is where it gets difficult when we use variable notation, because students here will say, I'll take the first times the derivative of y. Oh, the derivative of y is just going to be 1, right? Because we're just taking the derivative of a variable 1. No, it's y prime, because we're using it as we're using y prime as a substitute for what y prime would be if we knew what it was. Kind of like the same thing here, f of x and f prime. So the first times the derivative of the second plus the derivative of the first, which would be 2x times by y. So you can see that we just end up with the same thing here. Plus, now we'll do the derivative of this part right here. So we'll take x times the derivative of y squared. And so you think about this right here, like, oh, that's just going to be 2y. So times by 2y. And then a lot of students will say, we're done. Because, yeah, it's just using the power rule, right? But again, it's easier to see where the chain rule is needed here. If I think about it like this right here, we have function notation. We drop the 2, like we said, keep the inside as it is. And then now we have to go inside and take the derivative of that, which would be f prime. But it's harder to see when you use variables because you just treat it. You're treating, a lot of students will just treat y like it's x. Well, y is not x. Y is the dependent variable, while x is the independent variable. So then this would actually have to be 2y times by y prime, which would be the derivative of y. So that's the chain rule. And then plus, we'll take the derivative of x, and then that's 1 times by the second, so y squared, and that's equal to 0. So that's the tricky part when you're just using variable notation, is the temptation to just take the derivative of y as if you're taking the derivative of x, which is not, which is something you don't want to do. Okay. Now that we had that super long explanation, so we are trying to find dy dx. Dy dx is the same thing as y prime. So notice here that we have y prime, we have y prime here, and the next goal is to get these terms right here with y prime on one side and move these terms to the other side. So I'll keep this x squared y prime plus, I'll write this as 2xy y prime equal to negative 2xy minus y squared. Now that I have these terms with y prime in them, I can factor out the y prime. So y prime x squared plus 2xy equal to negative 2xy minus y squared. Now we can divide by all of this right here. So then y prime will be equal to negative 2xy minus y squared all over x squared plus 2xy. And yeah, that's that right there. Similarly with this 2 right here, again we have x and we have y squared, x squared and y. Both of these parts are going to require the product rule. So we're going to need the product rule, and we're going to need the product rule. Okay, I'm going to take the derivative just using, not switching it out for function notation, and that's what we need to get used to. Again, just your x and y squared have to be treated differently. X doesn't need the chain rule. Y does need the chain rule. Okay, so we'll say the first 2x times the derivative of y squared, which would be times by 2y. But again, thinking that y is not the same as x, you have to multiply by y prime, the chain rule. So we have the first times the derivative of the second plus the derivative of the first times by the second. Minus. This minus right here, I'm going to follow up with parentheses. That's always something that students tend to forget, is that when I use the product rule, I'm going to end up with two terms. And so the negative matters here because it would have to distribute, and that would change that sign right there. So just keep that in mind. So we'll take the first, which is 3x squared, times by the derivative of y, which is not 1. It's y prime. So we did the first times the derivative of the second plus the derivative of the first, which would be negative 6x when I take the derivative of this right here. Hold up though, that would be incorrect because I have the negative here, so and parentheses, so I actually have to exclude that when I'm taking the derivative. So it would be plus 6x. So we did the first times the derivative of the second plus the derivative of that times by the second, so times by y, equal to 6. Okay. Now I'll take the time to adjust the sign, so I'll remove the parentheses, but then I also have to make that negative right there. Okay, and then I'm looking for terms that have y prime in them, so those two terms right here. And so I will keep those, so I'm going to call that 4xy y prime minus 3x squared y prime equal to 6 plus 6xy minus 2y squared. And then I'm going to factor out the y prime, and then I'll have 4xy minus 3x squared equal to 6 plus 6xy minus 2y squared. And then I'm going to divide by this right here, and I'll get y prime is equal to 6 plus 6xy minus 2y squared over 4xy minus 3x squared. Okay. Another one very similar for 3. This doesn't need the product rule, but this will need the product rule. Okay, so the derivative of that first term will be 6x plus, so 5x squared. So we'll take the first times the derivative of y squared, which would be 2y y prime. So the first times the derivative of the second plus the derivative of the first times by the second equal to 2y prime. All right, now things that have y prime in them. So we have this y prime, we got this y prime. So that's going to be 10x squared y prime minus 2y prime when I move this over here, equal to negative 6x minus 10x y squared. Factor out the y prime, and then I'll have 10x squared y minus 2 equal to negative 6x minus 10x y squared. And then y prime will be equal to negative 6x minus 10x y squared all over 10x squared y minus 2. Okay. For 4, we have a tangent in here. Now, notice that we'll have to use the chain rule. And inside the chain rule, we'll need the product rule. Okay, keep that in mind. So we'll have the derivative of x, which would be 1, plus the derivative of tangent, which would be secant squared of xy. Now this is where the chain rule is going to happen. We have to take the derivative of the inside. So we'll have to multiply by the first times by y prime plus 1 times by y equal to 0. Now this part is kind of tricky. For solving for y, we have this y prime here. So separating this is hard because this secant xy should distribute. That's the hard part that we kind of forget, that to solve for this, I actually have to distribute this, and then I'll be able to separate this product that's happening right here. The product is what's difficult about that right there. So 1 plus secant squared of xy. I'm actually going to put that first. So we're multiplying this by xy prime. So I'll put that here. Xy prime times by plus y secant squared of xy equal to 0. Now you can see that this right here is the only term where we have the y prime. And so to get this by itself, we'll move this term and this term over. So we have xy prime secant squared of xy equal to -1 minus y secant squared of xy. And then I'll divide by all of this right here to get y prime by itself. So y prime will be equal to -1 minus y secant squared of xy over x secant squared of xy. For 5, looks like we'll have to use the quotient rule on this side. Now, we'll have to do the derivative of both sides. So we'll do 2y y prime for the left side equal to, now we'll have low d high, which would just be 1, minus high d low, which would be 1, all over x plus 1 squared. And then to get y prime by itself, we'll have to divide by 2y. So y prime will be equal to x plus 1. Let's simplify this right here. Minus x, but then we have a positive x, so that would actually cancel. 1, and then that would turn to plus. So we would have 2 over x plus 1 squared. And then because we're dividing this over here, that would just stay in the denominator. So we would have this, or we would have this divided by 2y over 1. But whenever you do a keep, change, flip, that would be times by 1 over 2y, which would then actually the 2 would cancel, and then you would just have y in the denominator here. So y prime will be equal to 1 over y x plus 1 squared. I'm just going to put this right here. Keep, change, flip, so that you guys don't flip out whenever you see this right here. Get it? Because I know you guys are going to be like, wait a minute. How do you go from here to here? Well, I divided by the 2y, keep, change, flip, and that's how I got that right there. Okay. Looks like it's the same kind of a deal. Excuse me. I have to use the quotient rule. So 2x will be equal to low d high. Now the derivative of the top would be 1 minus y prime. So low d high minus high. And then d low, which would be y prime, all over x plus y squared. Not looking good for us here. Maybe. I'm going to multiply this over here. So we get 2x, we'll get x plus y squared equal to, and then I'm going to distribute and kind of mess with this right here. We'll have x, and then we'll have x minus xy prime, then plus y minus y prime, and then the y prime and x, but it will be negative, so minus xy prime, and then minus y prime when I multiply that with, and then the negative right there. So can anything cancel? So we have x, negative x, y prime. No, I don't think so. So we have 2x and then x plus y squared equal to, well, I'm going to move this over here. So minus x, and then, let's see, that's a y prime, we got a y prime, got a y prime. So everything else is going to go. So minus y, oh wait, there's another y prime right there. I think that's everything. Equal to negative x y prime minus, well, and then we can combine like terms. So negative xy prime, negative xy prime, so minus 2xy prime, and then we have minus yy prime, minus yy prime, so minus 2yy prime. So we have 2x, x plus y squared minus x minus y equal to, we can factor out the y prime, and then we would have minus 2x minus 2y, so y prime will be equal to 2x, x plus y squared minus x minus y over negative 2x minus 2y. That sounds okay to me, but I don't think I can bother myself to check it, so I think I'm good. All right, just a couple more of these. So here, we'll just call that y prime equal to the derivative of the natural log. We're going to need the chain rule, by the way. So we'll need the chain rule. Don't forget that. I guess the chain rule would be all of it, but so we'll need the chain rule. So we'll have 1 over 3x plus 4y times by the derivative of the inside, which would be 3 plus 4y prime. Okay, now I'm going to, this is just in the numerator right here if you think about it. I'm going to multiply this over here. So we'll have y prime 3x plus 4y equal to 3 plus 4y prime. Now in order to group up the y primes, this y prime will have to distribute first. So we'll have 3x y prime plus 4y y prime equal to 3 plus 4y prime. And then this is the only term without a y prime. So 3xy prime plus 4y y prime plus 4y prime is going to be equal to 3. I can factor out the y prime, and I'll get 3x plus 4y plus 4 equal to 3. So I'll get y prime is equal to 3 over 3x plus 4y plus 4. All right. This one should be pretty similar. Y prime will be equal to 1 over 2x squared minus 3y squared. Now I'll have to multiply by the derivative of the inside, which would be 4x minus 6y y prime. And I'll move this over here. And I'm going to distribute. So since I'm multiplying this over here, I'll just distribute at the same time. So 2x squared y prime minus 3y squared y prime equal to 4x minus 6y y prime. I'll move this over here. So 2x squared y prime minus 3y squared y prime plus 6y y prime equal to 4x. I'll factor out the y primes. So y prime, 2x squared minus 3y squared plus 6y equal to 4x. And then I'll divide, so y prime will be equal to 4x over 2x squared minus 3y squared plus 6y. All right, now in these ones, we'll just be given a point to evaluate dy dx. All right, so taking the derivative of e to the 2y, well, the derivative of an exponential is always itself, but we'll have to multiply by the chain rule. So we'll have to multiply by the derivative of 2y, which would be 2y prime. Then minus, should I use parentheses? I don't know. I'm going to use parentheses. So minus e y squared minus y times by the derivative of the inside. I'm actually not going to use parentheses then. Which would be 2y y prime minus y prime. So that's the derivative of the inside part. And then equal to, since I don't want to run into that space, equal to 4x to the third minus 2x. Okay. And You know what? I'm not going to solve for y prime. I'm going to plug in these values for x and y, then I'll solve for y prime. So I'm going to plug in 0 here. So I'll have e to the 0 times by 2y prime minus e to the 0 when I plug 0 in for y right here, times by, if I plug in 0 here, that's gone, so times by negative y prime equal to, when I plug in 1 for x, that's just going to be 4 minus 2, so that's going to be equal to 2. E to the 0 is 1, so this will be 2y prime minus y prime, because e to the 0 is, that would be plus then, so plus y prime equal to 2. That's 3y prime equal to 2, so then y prime will be equal to 2/3. Okay, for this one, looks like it's pretty similar. So that will be e to the y times by y prime for the chain rule and the derivative of the inside, minus e to the y squared times by 2y prime, that's for the chain rule, the derivative of the inside, equal to 1 minus 3x squared. And then I'll plug in 0 for x right here, and then plug in 1 for y. So this will become y prime minus e times by 2y prime, because that's going to be 1, yeah, I think that's right, equal to 1. So that's ey prime minus 2ey prime equal to 1. We have ey prime minus 2ey prime. Is that negative ey prime equal to 1? So then y prime is equal to negative 1 over e, I think. Yeah, I think that's right. Okay, and that's it for those ones. I'll do a different video for these two free response questions.